Chapter 5.4 Function Notation. Key idea. By naming a function f, you can write the function using function notation. For example, fx equals 2x minus 3 is a function notation. So you remember that fx, we can write this as a standard notation, which means we can write this as y equals 2x minus 3. But when we write it as fx equals 2x minus 3, it becomes function notation. This is read as f of x equals 2x minus 3. This is called f of x. It's not a multiplication. So f is not, you cannot read that as f times x. So the notation fx is another name for y. So for example, you can write it here as y equals to x minus 3. That will be treated as standard form, and fx equals to x minus 3 is function notation. If f is a function and x is in its domain, means x has a value that are valid for that function, then fx represents the output or range or y value. So fx represents the output of f corresponding to that x values. You can use letters other than f for representing the function. You can write g of x, you can write h of x, j of x, and k of x. So for example, you can write the function as h of x, j of x, k of x, and g of x. So just like that, you write here fx, it can be any of these functions. Next is, what is function notation? Standard notation is as y equals to x minus 3, which we normally use, and you're very familiar with that, and we have used this in the past. For function notation, all you have to do is that this y you are going to use as fx, and that becomes function notation. For function notation, replace the y with fx. What does fx mean? F is the name of the function, x is the input value, and fx, or in other words, we can call it as y, and you know that y is output value, so fx is the output value or range. For function notation, you have to really be careful on not assuming f as a variable. So f is not a variable, and do not multiply f and x. So it's not a multiplication. We read it as f of x. Example number 1, evaluating a function. Evaluate function fx equals negative 4x plus 7 when x equals 2. So you're going to first write the function fx equals negative 4x plus 7, and then you're going to substitute x value, that is 2, for x place. So you're going to use x value, and you're going to write f of 2 equals negative 4 times 2 plus 7. So we're going to read it as f of 2 equals negative 8 plus 7, and f of 2 equals negative 1. So your range is negative 1 when x is equal to 2. You can also say that f of 2 equals negative 1. Example number 1, you try problem number 1. You're going to evaluate the function fx equals to x minus 5 when x is negative 4, 0, and 3. So you're going to plug that x value as negative 4. So f of negative 4 equals 2 times negative 4 minus 5. So f of negative 4 is negative 8 minus 5, that is negative 13. So the first number is negative 13 for the range. Now you're going to plug it in 0. So f of 0 equals 2 times 0 minus 5. So that's going to be 0 minus 5. And that's just 5, negative 5. And then the last is f of 3. So you're going to find the value of the function when x equals 3. So that's going to be 2 times 3 minus 5. And that's going to be 6 minus 5 and equals 1. So 6 minus 5 is 1. Chapter 5.4, you try problem number 2. You're going to find out g of x when x equals negative 4, 0, and 3. So first of all, we are going to plug it in x as negative 4. And we are going to find out the range or the y value at x equals negative 4, and that's going to be negative 5. The next is you're going to find out g of 0. So that's going to be 0 minus 1, and that's negative 1. The next is you're going to find out g of 3. That's negative 3 minus 1, and that's negative 4. For question number 3, we're going to find out f of 2. So that's going to be 3 times 2 plus 2. So 6 plus 2 is 8. Next is you're going to find out f of 0. So 3 times 0 plus 2, and that's 2. So next is you're going to find out f of 2. So that's going to be 3 times 2 plus 2. So 6 plus 2 is 8. Sorry, I made a mistake on the first one. So we should put negative 2. So that's going to be negative 6 plus 2. And instead of 8, we should get the answer as negative 4. And for the range, first one should be negative 4. So that's going to be negative 4, 2, and the last one is 8. So this one is 8. For number 4, you're going to evaluate fx equals negative 5x plus 3 when x equals negative 1, 0, and 3. So first of all, you're going to use negative 1. So you get f of negative 1 as negative 5 times negative 1 plus 3. So that's 5 plus 3 is equal 8. Then you're going to plug it in 0. So f of 0 equals negative 5 times 0 plus 3. So that's going to be 3. F of 3 equals negative 5 times 3 plus 3. So negative 15 plus 3 is negative 12. So the range is 8, 3, negative 12.